An AI trained on the oldest written language on Earth just did something that stunned researchers. It read a 5,000-year-old clay tablet from ancient Sumeria, and then it read another, and then another. And what it found inside those broken, dusty, fire-blackened fragments of clay was not just shopping lists or grain records. It was astronomy precise enough to match modern orbital calculations. It was mathematics so advanced it still runs inside your phone right now. It was flood stories that line up with actual geological evidence buried in sediment cores pulled from the Persian Gulf. And it was a body of knowledge so far beyond what anyone expected from people living in the desert of ancient Iraq 5,000 years ago that researchers at universities from Tel Aviv to California are still trying to explain how it got there. The Sumerians were not primitive, and AI is just now beginning to show us how sophisticated they actually were. This video is going to take you through all of it. The real science, the real discoveries, the real numbers. And by the time you reach the end, you are going to see the ancient world in a way that you have never seen it before. Subscribe right now because this channel is committed to bringing you the biggest discoveries in science and history explained in plain language. And drop a comment telling me where you're watching from. Now, let us go back to the beginning of this story because the beginning of this story is the beginning of human civilization itself. Around 5,000 years ago, in a stretch of flat, river-fed land between the Tigris and Euphrates rivers in what is now modern Iraq, something happened that had never happened anywhere on Earth before. A group of people called the Sumerians built the world's first cities, not villages, not camps. Cities with organized streets, irrigation systems, temples, storehouses, and governments. They invented the wheel. They invented large-scale agriculture. They invented the first known legal codes. And most importantly for this story, they invented writing, not pictures painted on cave walls. Actual writing, a system called Cuneiform, where you press a sharpened reed into wet clay and leave wedge-shaped marks that carry meaning. Specific, precise meaning. The same meaning every time. This happened around 3,400 to 3,300 years before the Common Era, making Sumerian cuneiform the oldest known writing system on Earth. Full stop. Now here is the problem that historians have been living with for over 100 years. Archaeologists have pulled somewhere between 500,000 and 2 million cuneiform tablets out of the ground across Iraq, Iran, and surrounding regions over the last century and a half. Museums in London, New York, Paris, Baghdad, and Istanbul hold enormous collections, and only a fraction of these tablets have ever been fully read and translated, because the number of people alive today who can actually read ancient Sumerian and Akkadian cuneiform fluently, the scholars who have dedicated their lives to mastering these extinct languages, that number is less than a few hundred people worldwide. A few hundred people, somewhere between 500,000 and 2 million tablets, and most of the tablets in museum archives are fragmentary, burned, cracked, and covered in symbols that overlap and contradict each other depending on context. One symbol in Sumerian could mean grain in one sentence and death in another, the same sign, different meaning. You had to understand the entire grammatical and cultural context to know which one applied. This is exactly the kind of problem that artificial intelligence is built to solve. And in the past few years, AI has started to crack it open in ways that are genuinely extraordinary. In 2023, a team of researchers from Cornell University and Tel Aviv University built a neural network trained on Akkadian cuneiform, the language that evolved from Sumerian and was spoken across Mesopotamia for thousands of years. They trained it on the open, richly annotated cuneiform corpus, one of the largest digital collections of translated tablets available, and they showed it could translate ancient Akkadian directly into English with meaningful accuracy for the first time. That was the beginning. In 2024, a dataset called Some Tablets was released, pairing over 91,000 Sumerian tablets with scholarly transliterations, giving AI systems raw material to work with in the older, more difficult Sumerian language. In 2025, a research challenge called Evacon specifically tested large language models on Akkadian and Sumerian tasks, including identifying grammatical forms, reconstructing damaged text, and predicting missing portions of fragmentary inscriptions. These were not flashy results. They were the quiet, incremental work that makes the flashy results possible. And then, in July of this year, 2026, a project called Tabletcraft was presented at an international conference on natural language processing alongside the Association for Computational Linguistics. Tabletcraft, developed by Zhaohui Wang at the University of Southern California, is the first open-source AI system that can do something no previous tool could do. It does not just translate ancient Akkadian into English. It can also take English and translate it back into Akkadian, convert that into cuneiform signs, and render the whole thing as an image that looks like an inscribed clay tablet. It is a two-way door between the modern world and the ancient one. Tabletcraft was trained on 116,000 bidirectional sentence pairs across multiple Akkadian dialects and time periods. It uses a lookup table, containing over 14,200 transliteration to Unicode sign mappings covering 95.3% of documented cuneiform vocabulary. On the academic validation test, it scored 49.1 on the BLEU translation quality metric for Akkadian to English. To put that in context, that is a score that linguists describe as approaching human-level fluency for the specific dialects it was trained on. This is real, published, peer-reviewed science. Not a rumor, not a YouTube claim. This was accepted to the C3NLP workshop at ACL 2026, and the code and the pre-trained model are freely available for anyone to download and use. So what is all this technology actually revealing? Because that is the question that matters. When AI reads these tablets at scale, when it can process thousands of fragmentary texts and look for patterns across all of them simultaneously, patterns that no single human scholar working over a lifetime could detect, what does it find? And the honest answer is both more ordinary and more astonishing than most coverage ever gets right. Start with the mathematics. Because this is the discovery that should genuinely stop you in your tracks when you understand what it means. Right now, today, in the 21st century, you live your life organized around a mathematical system, invented by the Sumerians 5,000 years ago. You do not use it because you chose it. You use it because it is so well designed that every civilization that came after the Sumerians adopted it, and nobody has ever found a better reason to replace it. The Sumerians used base 60 mathematics, which scholars call sexagesimal. A base 60 system means that instead of counting in groups of 10 the way we do in ordinary arithmetic, you count in groups of 60, and the number 60 has a remarkable property. It is divisible by 1, 2, 3, 4, 5, 6, 10, 12, 15, 20, and 30. That is 12 different whole number divisors. By comparison, 10 is only divisible by 1, 2, 5, and 10. 4 divisors versus 12. This made base 60 dramatically more powerful for calculations involving fractions, which ancient economies and ancient astronomers needed constantly. You know 60 seconds in a minute. That is Sumerian. You know 60 minutes in an hour. That is Sumerian. You know 360 degrees in a full circle. That is Sumerian. Your GPS satellite, which keeps time accurate to within 20 to 30 nanoseconds to know your position on Earth, is running on a definition of the second that traces directly back to Sumerian mathematicians, dividing the day into units of 60. As one researcher put it recently, every time you glance at a watch, you are looking at a piece of history that stretches back over 5,000 years. When AI systems processed the full corpus of Sumerian mathematical tablets, they confirmed something scholars had suspected but never fully mapped at scale. The Sumerians did not just use this base 60 system for simple counting. They built multiplication tables, tables of squares and cubes, tables of reciprocals, algorithms for solving what we would now recognize as quadratic equations. These were not primitive people doing basic arithmetic. These were engineers and scientists doing the mathematical heavy lifting required to build cities, manage massive irrigation projects, and track the movement of the stars across the sky with enough precision to predict future events. And that brings us to the astronomy. Because the Sumerian astronomical records, when AI reads them at scale and connects the fragments that human scholars working individually could never connect across thousands of separate tablets, reveal a systematic observation program of the night sky that is breathtaking in its scope and accuracy. Long before the Babylonians built their famous observatories, long before the Greeks systematized astronomy, the Sumerians had already identified and named the constellations we still use today. They had already mapped the 5 visible planets, Mercury, Venus, Mars, Jupiter, and Saturn, tracking their movements across the sky with recorded observations stretching back across centuries. They had already divided the sky into the 12 sections we still call the zodiac, a conceptual framework that came directly from their base 60 mathematics applied to the 360-degree circle of the heavens. They understood the difference between stars that stay fixed relative to each other and planets that wander. They understood the ecliptic, the path that the sun and moon and planets follow across the sky. And they built this understanding through systematic observation and recording over generations, preserving it in clay that survived when every other civilization's records rotted away. The Sumerian texts also describe astronomical events that match real-world occurrences. Descriptions of Venus appearing and disappearing from the sky as it moves through its orbit, appearing first as an evening star and then as a morning star. Cycles that are recorded in the Venus tablets of Ammisaduqa that date to around 1600 BCE and have been verified against modern planetary calculations. Descriptions of lunar eclipses that scholars have matched to actual historical eclipse records. When AI cross-references these observations against modern astronomical databases, the matches are real and they are precise. These were not random stories about gods in the sky. These were observations, recorded, dated, archived, preserved in clay for 5,000 years. Now, let us talk about the flood, because no aspect of Sumerian literature has generated more debate, more misunderstanding, and more genuine scientific interest than the flood stories embedded in the tablets. Most people know the flood story from the Epic of Gilgamesh, the world's oldest known work of literature, which tells the story of a great flood sent by the gods that destroys almost all of humanity. Survived only by a man named Utnapishtim, who builds a great boat and fills it with the seeds of life. This story predates the biblical account of Noah by at least 1,000 years, but what makes it genuinely interesting to modern scientists is not just the literary parallel. It is the question of whether there is real geological evidence for a catastrophic flood event in ancient Mesopotamia that these stories were recording. The answer is yes, and it is specific. Sediment cores pulled from the Persian Gulf by geological researchers show a massive flood layer dating back to around 5,200 years ago. That date, 5,200 years before the present, falls right inside the timeline of the earliest Sumerian civilization. The sediment layer is not ordinary flood mud. It contains burnt organic particles, charred seeds, blackened minerals, the chemical signatures of an event far more intense than a normal seasonal flooding of the Tigris and Euphrates rivers. Modern geological analysis suggests this sediment layer could be consistent with the aftermath of a major solar event, a seismic episode, or some combination of environmental catastrophes that would have fundamentally disrupted the landscape of early Mesopotamia. The ice core records from Greenland and Antarctica show unusual spikes in cosmic radiation during the same general time period, markers that scientists use to track major solar and cosmic disturbance events reaching Earth's upper atmosphere. Were the Sumerians recording a memory of this actual event in their flood myths? The honest scientific answer is that the correlation is real and compelling, and that the geological and literary evidence are pointing at the same general period in time. This does not mean the Sumerian flood stories are literal transcripts of what happened. It means they may be cultural memory, preserved in narrative form across generations, of an actual catastrophic event that early Sumerian civilization experienced and survived. The people who wrote these tablets were not making up random stories. They were preserving something that mattered to them, something that shaped who they believed they were and why civilization had nearly ended and had to be rebuilt. That is a profoundly human thing to do, and it is increasingly well supported by the physical evidence in the earth itself. Now, here is where the Sumerian story becomes most interesting in relation to what AI is doing right now. Because one of the most exciting capabilities that large-scale AI translation is giving researchers is the ability to look across the entire surviving corpus of Sumerian and Akkadian texts simultaneously and find connections that individual scholars working on individual tablets over individual careers could never see. And when researchers do this, something remarkable begins to emerge. The Sumerian knowledge system was not just locally developed and locally preserved. It appears to have influenced, and to have been influenced by, knowledge traditions across a far wider geographic range than traditional history has fully accounted for. The Sumerians were not isolated. They were traders. They ran sea routes down the Persian Gulf into the Indian Ocean and made contact with the Indus Valley civilization, the great urban culture that flourished in what is now Pakistan and northwest India around the same period. They traded with Egypt. They had connections to cultures across Anatolia, modern Turkey, and across the Iranian plateau. When AI systems flag consistent patterns, mathematical relationships, and structural similarities between Sumerian texts and records from these other ancient civilizations, what they are finding may not be evidence of mysterious lost civilizations or supernatural origins. It may be evidence of something even more interesting, a real ancient world that was far more connected, far more actively communicating, and far more mutually influencing than the isolated self-contained civilization model that older archaeology assumed. The cuneiform sign for the sun, for example, appears across multiple ancient writing systems in forms that share structural features. The mathematical ratios embedded in Sumerian astronomical calculations appear in Egyptian temple geometry and in the proportional systems used in Indus Valley urban planning. Whether these are the result of direct contact, shared trading of knowledge, or parallel development in response to the same universal astronomical observations is still genuinely debated. But AI is giving researchers the tools to map these connections at scale for the first time, and what is emerging is a picture of the ancient world as a place where knowledge moved, where people traveled, where ideas spread, and where the remarkable intellectual achievements of one civilization could seed the thinking of others thousands of miles away. The Sumerian tablets also contain something that modern researchers studying the history of science find genuinely extraordinary. Evidence that the Sumerians understood not just what was observable in the sky, but predictive patterns in astronomical cycles. They could predict eclipses. They could predict the return of Venus to its position as morning star. They tracked the Saros cycle, an approximately 18-year pattern after which lunar and solar eclipses repeat in the same sequence. These are not the observations of people looking up at the sky and drawing pictures in the mud. These are the records of systematic scientific observation, maintained across multiple generations, organized in a format designed to extract predictable patterns from long-term data. In other words, the Sumerians were doing something that looks recognizably like science, long before the ancient Greeks are typically credited with inventing the scientific method. What AI translation is doing right now is making this visible at a scale that was simply impossible before. Hundreds of thousands of tablets that have sat in museum storage for decades, labeled but unread, are now candidates for automated preliminary translation that can flag which ones are interesting enough for human scholars to examine more carefully. In the 2025 Evacon Research Challenge, AI systems demonstrated the ability to lematize Sumerian and Akkadian text and predict missing portions of damaged inscriptions with meaningful accuracy. This is the equivalent of taking a broken clay tablet with words missing at the edges or in crumbled sections, and having the AI make educated, linguistically grounded guesses about what the missing words were, based on everything it has learned from the corpus of tablets that are already fully translated. This is not perfect. It is not infallible. But it dramatically accelerates the process of making broken tablets readable enough for human experts to work with. The TabletCraft system released in July 2026 takes this further by making the tool freely available to anyone: researchers, historians, university students, curious members of the public. The code is on GitHub. The model is downloadable. A non-specialist who has no training in Cuneiform can now feed an image of an ancient tablet into this system and get an English translation output within seconds. This is genuinely unprecedented. For the vast majority of human history, the written records of the world's first civilization were locked away behind a language barrier that only a tiny number of specialists could cross. That barrier is now crumbling. And as it crumbles, the Sumerians are becoming legible to the world in a way they have not been since their civilization fell more than 2,000 years ago. What is going to happen as the remaining hundreds of thousands of unread tablets are processed is anybody's guess. Scholars are cautious, as they should be. AI translation is not perfect. It can make errors. It can miss nuance. It works best on well-attested dialects and struggles more with rare texts or very early Sumerian. The consensus among professional Assyriologists is that AI is a powerful tool that augments and accelerates human scholarship rather than replacing it. A machine can flag a tablet as containing unusual content. A human expert still needs to examine it carefully and verify the translation. The field is approaching this technology with appropriate rigor, but the direction is clear. We are going to read more Sumerian tablets in the next decade than in the previous century of scholarship. And what they contain is going to keep surprising us, because what 5,000 years of Sumerian writing already tells us, even with what has been translated so far, is that the people who built human civilization from scratch were not simple. They were not primitive. They were not stumbling around in the dark waiting for someone smarter to come along. They were mathematicians who built a number system so efficient that every civilization since has adopted it unchanged. They were astronomers who tracked the movements of planets across centuries with systematic precision. They were storytellers who recorded catastrophic events in forms that preserved memory across generations. They were traders and builders and engineers who connected the ancient world across thousands of miles. And they wrote all of it down, pressed into clay with a sharpened reed, in a form so durable that 5,000 years later a machine trained in their language is reading their words and handing them back to us. The Sumerians left a message in clay. It took us 5,000 years to build a tool smart enough to read it at scale. And now that we have, the message turns out to be exactly what you would expect from the world's first civilization. We were here. We understood things. We recorded what we knew. And we left it for whoever came after us. That is what civilizations do. That is what humans do. And now, for the first time in 5 millennia, we are finally answering back. If this kind of deep, evidence-based history is what you come here for, share this video right now with someone who needs to know how extraordinary the ancient world actually was. Drop a comment below telling me which part of this story hit you hardest. Was it the math, the astronomy, the flood records, the AI breaking the language barrier that held for a century? Tell me what got you, and I will see you in the next one.